Math Marbles, in this lesson, we're going to look at a peer's work and try to evaluate it and see if we can give them some feedback. We're also going to check for accuracy, and that means a few things. We're going to look to make sure that their work is mathematically sound. Does it follow a procedure that makes sense? Are their calculations correct? And even though we're going to be using calculators, can we verify their answers and their calculations? So I'm also going to be using a calculator app on the right side. The way it works is I can type in different numbers, I can write them in, and it'll give me an answer pretty easily. So I'm going to try using both of them at the same time to verify it. So again, we're going to look at some student work, or in this case, some adult work, and try to figure out, is there an error? If there was, who made it? And what is the correct answer? So in this problem, we have, it looks like a cylinder, but notice there's a little indentation. So a piece of it is carved out. And we're going to try and figure out the volume of the cylinder and see if their work matches our thinking. So we're going to start with Miss G. And here's her work over here. And let's see if we can follow through her process about what she did. You can see she separated the volume of the cone from the volume of the cylinder. And the cone part is up here. There's her cone. And the rest would be the cylinder. And looking at the work, we have the height already identified, and we know that we're going to use radius in these problems now. Radius goes from the center to the end, so take a quick look. We see the number 8 here, which represents the diameter. So if diameter equals 8, we know the radius would be half that, or 4. Okay, so I think we have all the information we're going to need. Let's jump into our work. We have a volume formula for the cone, 1/3 pi r squared times the height. So we have a formula, just a formula. It's a correct formula for a cone, and a formula for volume of a cylinder. Both are correct. And so the very first part, she has 1/3 is equal to 3.14, so that's where she's subbing in pi, and 4 squared, so her radius is 4, times 1.4, which is the height. So I can see where she's getting all these numbers from. She's just subbing in pi, 3.14, the radius is 4, and the height, well, for the cone, it's just 1 4/10. The height for the whole cylinder is 16. Okay, so let's just verify and check the numbers since we know that her substitutions are all correct. Okay, so I'm going to write it here on the side. 3.14 times 4 squared times 1.4 times 1/3. All right, and you can see my calculator tells me 23.445, and it keeps going. And we can see she got 23 and 4,500, so it's the same. It's just rounded. So it matches my work pretty well. Okay, let's look at the cylinder. So I'm going to erase that for a second. She has the right formula. You can see where she did the substitutions. Again, here's pi. Here's her radius squared. Here's the height for the big cylinder. So I'm going to do the same thing. 3.14 times 4 squared times 16. And we're getting 8.0384. So the exact same numbers. So again, my work for the cone, I had the exact same number, 23.446, which does round to 23 and 4/5. And for the cylinder, I ended up getting a volume of 803 and 84 hundredths. And both of these are in inches cubed. So let's not forget that. All right, so her final step is she's going to do the cylinder and take away the piece of the cone. So that makes sense. So I'm going to do the same thing. 803 and 84 hundredths minus 23 and 45 hundredths. All right, and I get 780 and 39 hundredths. And again, I'm just showing my work to make sure that it's confirmed. I'm getting 780 and 39 hundredths. And you can see all she did was rounded. So this confirms. Miss G's work pretty much matches mine. I don't see an error. I see her process, and her process makes sense. Her substitutions make sense, and her calculations make sense. So now we're going to try with Lydia's, and she's starting the same way with a formula for both. That makes sense. And let's look at her substitution. So I see pi, and up here's the difference, Math Marvels. For radius squared, I'm seeing 8 squared. And again, like taking a look here, 8 is our diameter. So that is where the error is. And so we're going to identify that right here. This is an error. Okay, and it happens again with the cylinder where we have the right height, we have the right number for pi, a nice approximation, but there's an error here. So I'm going to put this in my answer. I'm not going to go through the calculations point. I do want to just note the error. So I'm going to put this in my explanation. Who made the error? Miss L made an error. She used the diameter 8 inches instead of the radius 4 inches when calculating volume for the cone and her cylinder. Okay, so we've answered all those questions. The last part I have to answer is who is correct. Miss G is correct. Okay, so we're gonna hit pause there and jot this down into your notes. And again, I'm just elevating how when I'm looking at someone's work, I'm looking for their process first. Does their process make sense? Can I see the work that we're doing? This is why it's so important to have our thinking on the page so we're not guessing. And then we're also looking to make sure that the calculations are mathematically sound. And the great thing is that we can plug in those same numbers on our calculator to see if we're going to get the same answers. Now, just like with Miss G, we see that she did some rounding, and that is okay. That is sound mathematical process. Okay, we're going to do the exact same thing again. We have a new problem. We're going to look at student work and try to evaluate, is the process correct? Is there an error that we can identify? If so, how do we fix it? And if there's no error, we're just going to write the word correct. So let's start by reading through the problem. A cylinder and a cone have the same volume. The cylinder has a radius of 2 inches and a height of 3 inches. So that's important. Let's radius of 2 and a height of 3. That's the cylinder. And the cone has a radius of 3 inches, and we want to figure out what is the height. So that's the problem. We're trying to figure out what is the height. All right, so let's look at what they did. And the first thing we see them doing is they're taking the cylinder, and I love that they're labeling it and they're separating cylinder from cone. Great. This is fantastic to do, really making sure you're labeling your work. And they're starting off with a formula. So we see the formula. Is that the right formula for volume of a cylinder? So I want us to think, Math Marvels, is this the right formula? And unfortunately, no, this is incorrect. This is the formula for volume of a sphere. because a sphere has that fraction in the front part. For a cylinder, it is just pi r squared times the height. It's just the area of the circle times the height. So that is an error. You can see that throughout the problem, they are using, like he's using the right radius and using the right height, and he's approximating for pi, but this part is what makes it wrong, because that is just not necessary to our problem. So we've already identified what that is. All right, so let's just correct it. If he used the right formula, volume equals pi r squared times height, he would have 314 times 2 squared times 3. Let's use our calculator to figure this out. 314 times 2 squared times 3 would give us 37 and 6800 inches cubed. So that's the volume for the cylinder. That's what it should be. And you can see how off he is. He's off by about 13 cubic inches. All right, so let's look at the cone. And the cone, again, he's starting with the formula. And that is the correct formula for a cone. So that part is correct. So now he's doing the substitutions. That was always the next step. We're going to substitute. And you can see he substitutes 3 and 1400s for pi. Let's see, the radius is 3 for a cone. Yes, he took that. And this is the unknown. So here's the other part. He's substituting. Where is he getting this number? It's because they're saying the volumes are the same. So he's just using this number and he's subbing it in for the volume. So that's where that error is that he's using the wrong volume. Okay, so we're going to do the same thing. Volume is equal to 1/3 pi r squared times height. But this time we're going to use the correct volume as we substitute. So 37 and 6800 is equal to 1/3 times 3 and 1400 times 3 squared times height. All right, let's substitute. I'm going to use my calculator again, and I have 1/3 times 3 and 1400 times 3 squared. And that gives us 9 and 4200. And I still have the height. I don't know what my height is. I don't have a number for that. But I know that's equal to 37 and 6800. So now my next step is I'm going to divide by 9 and 4200. And that will leave me with h on one side. Okay, so let's do that. 37 and 6800 divided by 9 and 4200. And that gives me 4. For my height is equal to 4. Okay, so super helpful. Again, having a calculator really helps me just do the calculations, but you can see my thinking on the page. All right, so let's go to an explanation. There is an error in the work. The student used the formula instead of volume of a cylinder. The actual volume is 37 and 68 inches cubed. When you use the correct volume, you can find the height of the cone, which is 4 inches. So pause there. I said whether or not it was correct. I did that. I described the error in words. I did that. And I showed how to fix it when I used the correct volume. And I am done. So we can hit pause. So you can jot this down into your notes. And again, the biggest takeaway is when you're looking at another person's work, you're really looking to see what is their strategy, is it mathematically sound, does it make sense, and are your calculations correct? And having that type of thinking and awareness of another person's work is just going to make us more mindful and aware when we're doing our work. And you can really also see the value of having your thinking visible, because as you're evaluating, you can see how easier it is to follow through and follow along with someone's work. And that is the same thing someone should do when they're looking at our work. We want them to be able to follow along and see our thinking and our process so they can give us great feedback as well. So that's it for today's lesson, Math Marble. I hope this was useful. Remember, you're going to use the same process in your practice for today. See you in the next lesson. Take care.